Limited growth. The mathematical model for limited growth is y equals c times the quantity of 1 minus e to the power negative kt, where c and k are positive constants. As t increases, the quantity e to the power negative kt is the reciprocal of e to the power kt. The denominator gets larger and larger or becomes infinity eventually. That makes the term 1 over e to the power kt approaches 0. Overall, as t increases, the term y will approach the value c multiplied by 1 minus 0, which is the value c as you see in the graph. The graph started at t equals 0 or the quantity 0. The graph is increases. Eventually, the graph approaches to the horizontal line y equals c, which is the limited value of the growth. For this example, suppose that a man learning to make widgets can make n equals 100 multiplied by 1 minus e to the power negative 0.3 t. If you compare with the model of the limited growth, the c value is 100 and the k is 0.3. This number represents the number of widgets per week after 2 weeks on the job. In part A, about how many widgets will this man produce during his 4th week on the job, and part B, at what rate will his widget making skills be improving at the end of 4th week and the 10th week. For part A, we are going to compute the n or the number of widgets during his 4th week. So n equals 4. For part B, we're going to compute the rate, which is the n prime. So I'm going to put a note over here. In part B, we're going to find the rate, which is the n prime at 4 and n prime at 10, which is the rate of the skill or how many widgets that he can make per week. So in part A, to compute n of 4, we just replace the t with the number 4. We get 100 multiplied by 1 minus e to the power negative 0.3 multiplied by 4. Replace the numbers or use the calculator to compute the value of n.4. I'm going to share the screen of the calculator so we can see how the number comes out. So type in 100, multiply, open the parentheses, 1 minus the letter E, which is the notation above the ln, and negative sign, 0.3, multiply by 4, close the parentheses, actually move it and delete, and the parentheses will be closed when the cursor is down, and then enter. Now we get 69.88. Or it's about 70 widgets that he can make per week. That he make during the 4th week on the job. For part B, we are going to find the rate of change or the n prime at 4 and at 10. From the function that we have, we find the derivative with respect to t. Or the n prime at t, which the derivative of 100 multiplied by 1 minus e to the negative 0.3 t. We treat 100 as a constant multiple. Then the n prime at t will be 100 multiplied by the derivative with respect to t of 1 minus e to the negative 0.3 times t. Derivative of the difference is the difference of the derivative. So we're going to find the derivative of the 1 with respect to t and the derivative of e to the negative 0.3 t. Derivative of the 1 is 0. And the second part, the derivative of the e to the negative 0.3 t. We consider negative 0.3 t as one function. So I will name it as g of t. Recall when you find the derivative of the e to the power of the function, we use the chain rule as e to the power of the gt multiplied by the g prime at t. In our case, the g at t is negative 0.3 t. Therefore, the g prime at t is negative 0.3. So from this information, we're going to use to find the derivative of e to the negative 0.3 times t. Now we get 100 multiplied by 0, which is the derivative of the 1 with respect to t, minus e to the negative 0.3 t times negative 0.3. And simplify the m prime at t to be 100 multiplied by 0.3 e to the negative 0.3 t, because the negative sign here and the negative sign here multiply becomes positive inside. And simplify further to get m prime at t as 30 times e to the negative 0.3 times t. Now we are going to compute at 4 and at 10. So n prime at 4 equals 30 times e to the negative 0.3 multiplied by 4. And n prime at 10 is 30 times e to the negative 0.3 multiplied by 10. We're going to put in a calculator to get the number or the value that we're looking for. So the first one is 30 multiplied by e second and the ln to see the e to the power. Enter negative sign 0.3 multiplied by 4. Move the cursor down, enter. The first number is 9.0358 and the second one for n prime at 10 going to be 30 multiplied by e to the power negative 0.3 times 10. Enter to get the value 1.4936. So bring the numbers to the main part of the problem. N prime at 4 is 9.04 and n prime at 10 is 1.49. So round to the whole number or to the nearest one decimal place. So going to be about 9 digits per week for the rate of change at 4 and about 1.5 digits per week for the rate of change of the n at the week 10, at the end of the week 10.